Hello and welcome. My name is Max and I'm the team leader of Team Eagle. Spruce's Helpicams is an AI-assisted wearable camera project that is designed to record and provide up-to-the-moment tracking of where cleaners are up to in their cleaning of hotel rooms. When we originally took on this project, we took it on under the premise that the project room recognition section was completed and was up and working and being used by the cleaners and their supervisors in the hotels that they were working in. It turned out that this project was not as far as expected, and in the end, it was settled that if we could get the room recognition and entry and exit records working, the client Leo would be content and would have a project to pass on to the next USQ team, who would then find it much easier to complete the overall project.
Hi there, my name is Marita and I assisted with the database design and a little bit of the backend integration for this project. I'm going to explain just a bit about the high level design plan for the Helpy app and what additions were actually made by the team to this existing web application. So what we have in front of you here is just a visual display of both the front end and back end outputs for the existing Helpy web app. As you can see, the front end includes the mobile application, which creates a camera feed through the Helpy app. And then this feeds to the web application for admin users to track things like video feeds and data, tasks, and user information. So the backend processes all of this input from both applications. It authenticates the users and it stores data in a database to send to the front end web application display. Now, the primary request from the client was to have image and activity recognition that would actually process the camera feeds from the mobile app to identify room numbers and actions that the cleaners were taking, cleaning actions. So the concept was that these results would then display on the web application for the admin user for things like quality control when monitoring video feeds, because it would effectively list the actions and locations of the cleaners as they worked. An existing YOLO image recognition model had already been created that recognized room numbers from a video feed, but as shown here, it's sort of sat outside the existing Amazon web server for the web application. It was operating completely independently. Okay, so how does this look? As you can see, there's a couple of images here that give you sort of a live picture of how these applications run. You've got the mobile application on a phone, which is just that, a live camera feed. And the result on the web app side is that you're seeing that feed with some information around it. And ideally what the client wanted next to that feed was a list of rooms being recognized and actions being recognized in that camera feed and the times they were taking place. So the challenge then for the team was to create this, a running display on the front end that listed all of this information and the times cleaning tasks were taking place. So in order to do that, there were several aspects that needed to be addressed. So one of those was creating additional database collections. The existing application already used MongoDB and had existing collections for user data and camera and hotel data. Creating additional database collections to take in room recognition and task recognition and store that data was required. Then there was significant work in the back-end code to integrate those AI recognition models. So the existing YOLO room recognition model operated completely independently, and integrating that was a monumental task that required access to Amazon Web Server, Kinesis video instances, finding where to integrate it, where to trigger the recognition, and how to submit those results to the database. Then there was also gathering the additional image and video data of these activities, cleaning activities, such as vacuuming and mopping, making the bed, augmenting these and creating activity recognition models that would identify these cleaning actions. And finally, creating that front-end feed that would display these results from the database. So the team approach to this was to divide and conquer. We shifted into front end, back end, and activity recognition subgroups to make those additions to the code, both front end and back end.
Hi everyone, my name's Chris Parker. Now, as already mentioned, an earlier university team has actually developed a model to recognize room numbers from a video stream. And other members of our team, particularly Malera and Max, have focused on the actual technical changes required to the web app to make this work. My role has actually been predominantly to integrate all these three components from previous university teams, Max and Moretta's changes into the web app. So let's actually see how it operates. So here I'm actually taking on two roles. I'm logged into the application, which would be typically the manager or supervisor's role, but I'm also playing the role of a cleaner. So I've actually got a live stream running from my phone, and I'm actually streaming, looking at the app. So you can see me looking at the app down the tunnel. So what I'm actually going to do on the second screen across to my right, I actually have a picture of a hotel room door. So in a moment, we will see the screen pan across. So it's now actually looking, this is the actual live stream, this is what I'm looking at. It looks at a picture. Now the actual frames are extracted approximately every 3 to 5 seconds. So ideally the cleaner will just stop in front of the door for a second. And here, as I've refreshed the screen, you can now see the room number initially detected slightly inaccurately, 179, but it's actually corrected itself to 149. And I'm actually going to go on to a different picture. Again, this is live, this is happening, there's no delays. I'm actually looking at a room number 332. I'll refresh the screen very shortly. Here we go. The screen's about to refresh, and you can see it actually recorded it twice because I was standing in front of the door long enough. So ideally, a cleaner on entering a room will have that sort of 5 to 10 second standing in front of the door, just so we can actually make sure we get the images extracted. All right, thank you. So in this slide, things are actually getting a little bit technical, but what I want trying to demonstrate is that in the background within AWS, so as a cleaner logs into their camera, and in this case it'll be when I launch the camera screen, a what AWS term as a compute instance, but you can consider it to be a virtual machine. It's actually instantiated and loads up, fires up. It runs in the background. So one of these virtual machines will run per cleaner. So as they're streaming, each one has their own dedicated virtual instance running in the background, extracting images and recording. So it doesn't matter how many cleaners we have, they all have a dedicated environment to actually do the extraction of the data and store it into the database. Now, this is regardless of whether anyone is actually looking at a video stream. This will all happen as they log into their cameras. Lastly, I would actually just like to cover a little bit about how the changes can be deployed from our testing environment into the real environment. All the code changes have been integrated into the Git repository, including the new actual background model that runs for detecting the room numbers. That's all part of a Git repository, and a pull request has actually been put in place. The other change, which is actually some AWS configuration that needs to apply, is how we manage these effectively virtual machines. I will explain this in more detail in the appendix of the actual report. So for the technical changes, please have a look at that appendix. Thank you.
My responsibilities mainly involved data collection and annotation. Of course, I encountered some issues during this process, primarily watermarks in the collected data, converting video data into images, and some missteps during annotation. due to a lack of understanding of the AI model's intended functionality. However, through discussion and help from my team members, these issues were quickly resolved.
Our next slide is model selection. We choose YOLO 11 because it delivers the perfect balance of accuracy and efficiency. This model processes data quickly with minimal hardware demands, which allow real-time and reliable object detection. Its robustness ensures strong performance in different environments, and its flexibility supports further upgrade, making it ideal for our AI-powered project. Our next slide is a resultant performance metrics. After training, we evaluated our model performance. We used YOLO 11 Nano, a lightweight architecture with 100 layer and around 2.6 million parameter, achieving efficiency performance at 6.3 G-flops. The model achieves a strong mean average precision at 50%, indicating reliable detection and localization. Breaking it down by activity, betting score 0.85, mobbing achieved nearly perfect 0, which is 0.99. Vacuum had 0.73 and washroom detection reached 0.69. Our confusion matrix reveals overall accuracy of 75%, confirming the model generalization capability. In conclusion, YOLO 11 Nano delivers high precision and recall with robust performance across all 4 activities, even on very small data.
In terms of the next steps, first we need to collect and process a larger data set of cleaning and cleaning related images. This will improve our model accuracy in recognizing different cleaning action under various lighting and room conditions. Second, we plan to start implementing real-time task recognition where the system can identify the specific activity like vacuuming or dusting as it happens. Third one is recognition is working reliably. We fully test the system, fix any bug and polish the code bases. Finally, we aim to publish the clean and documented version of the program on a GitHub. The client can easily integrate into their existing hotel management system. Overall, the journey so far has been an exciting blend of computer vision, cloud computing, and software engineering. And we look forward taking this prototype to a more professional and scalable level. Thank you.
In conclusion to this project, we were able to get the room recognition and the time and date stamp recording working. As a bonus, we got these showing up as a text message sent to an activity log box on the main screen of the supervisor's mobile device that they use to monitor the cleaner's progress in their work. In addition to this, we were also able to do much of the preparation of the images for the activity recognition part of the project so that when it comes time for the next USQ team to take over, they can simply work on integrating the images into the activity recognition part of the project. This will eventually get the entire project working to the client's satisfaction, hopefully very soon.